Tonight, you're going to set an alarm. It's going to go off tomorrow morning. You're going to reach over, turn it off, sit up, and start your day. And you're going to assume that you're awake. You're not. Not fully. Not for a while. And the decisions you make in that window, the things you say, the car you drive, the choices that feel completely normal, are being made by a brain that is still, in a very measurable and documented way, partially asleep. This isn't a metaphor. This is neuroscience. And it changes everything you think you know about the most ordinary moment of your day. Let's start with what actually happens when an alarm goes off. Your brain doesn't switch from sleep to wakefulness the way a light turns on. There's no clean flip. Sleep isn't a single state you leave behind. It's a complex biological process, and pulling out of it takes time. The moment your alarm wakes you, your body begins a transition. Your heart rate increases. Cortisol begins to rise. Your core temperature starts climbing. All of this is happening automatically beneath your awareness. But your prefrontal cortex, the part of your brain responsible for logical thinking, decision-making, impulse control, and self-awareness, is still offline. Not metaphorically offline. Scientists call this sleep inertia, and it's been documented for decades. Sleep inertia is the period immediately following waking when cognitive performance is significantly impaired. Reaction times are slower. Memory recall is degraded. Decision-making is compromised. Attention is fragmented. In 2006, researchers at the University of Colorado published a study in the Journal of the American Medical Association. They compared the cognitive performance of people who had just woken up to people who had been awake for 26 hours straight, the equivalent of a full day with no sleep at all. The result was striking. In the first few minutes after waking, cognitive performance was actually worse than after 26 hours of total sleep deprivation. Read that again. The moment you wake up, your brain is performing worse than it would after being awake for an entire day. You are, in a measurable sense, more cognitively impaired right after waking than you would be if you simply hadn't slept at all. And most people walk straight from their bed into their morning without knowing this. They check their phone. They read emails. They have conversations that matter. They make decisions about their schedule, their relationships, their work, inside a window where their brain is operating at its lowest functional capacity of the entire day. Now here's where it gets complicated, because sleep inertia doesn't feel like impairment. That's the cruel part. When you're drunk, you feel drunk. When you're exhausted at midnight, you feel exhausted. Those states come with signals. Your body tells you something is off. Sleep inertia doesn't do that. It feels like normal waking. You feel like you're thinking clearly. You feel like you're present and functional and making reasonable judgments. You're not. Researchers call this the subjective-objective gap, the gap between how functional you think you are and how functional you actually are. And in the state of sleep inertia, that gap is wider than at almost any other point in a normal day. You don't know you're impaired. And that's exactly what makes it dangerous. Think about what happens in the first 30 minutes of your morning. Parents making decisions about their children. Doctors arriving for early shifts. Pilots going through pre-flight checks. Truck drivers pulling out of depots. Emergency responders waking for calls. All of them operating in a window where their brain is objectively performing below its normal capacity. All of them feeling fine. The research on this is sobering. A 2004 study published in Sleep found that errors in complex tasks were significantly elevated during sleep inertia. A 2019 review in the journal Current Biology found that sleep inertia effects on cognitive performance can last anywhere from 1 minute to 4 hours depending on prior sleep quality, the stage of sleep you were in when you woke, and how abruptly the waking occurred. Up to 4 hours. Think about your morning. How much it falls inside that window. But here's the part that changes how you think about this entirely. Sleep inertia isn't a flaw. It's a feature. Your brain doesn't wake up slowly because something is wrong with it. It wakes up slowly because the transition from deep sleep to full alertness is a complex neurological recalibration that takes time to do correctly. During deep sleep, particularly slow-wave sleep, your brain is performing critical maintenance, consolidating memories, flushing metabolic waste products through the glymphatic system, restoring neurotransmitter levels, rebuilding the neural pathways that learning and attention depend on. Waking up is an interruption of that process. Sleep inertia is your brain finishing the job before it hands control back over. The grogginess you feel isn't your brain failing to wake up. It's your brain completing the work that sleep started. And when an alarm cuts that process short, which it almost always does, your brain is forced to hand over the keys before the job is done. This is why the stage of sleep you're in when you wake matters enormously. Sleep comes in cycles of roughly 90 minutes. Each cycle moves through lighter stages, down into deep slow-wave sleep, and back up through REM, the stage associated with dreaming, emotional processing, and memory consolidation. If your alarm pulls you out of deep slow-wave sleep, sleep inertia hits hard. The contrast between where your brain was and where it suddenly needs to be is enormous. If it pulls you out of light sleep near the end of a cycle, the transition is smoother. The brain was already on its way back up. This is why waking up at the same time every day, even on weekends, actually makes mornings easier. It trains your body's circadian rhythm to anticipate waking and begin the transition before the alarm even goes off. Your brain starts climbing out of deep sleep on its own schedule, so by the time the alarm rings, you're already near the surface. It's also why those claims about sleep cycle apps aren't entirely wrong. Waking at the right moment in your sleep architecture genuinely changes how you feel and how you function when you open your eyes. Now here's the question nobody asks. If sleep inertia is universal, if every human being on the planet wakes up cognitively impaired every single morning, why don't we build our mornings differently? Why do we schedule 8 a.m. meetings? Why do school start times run on industrial-era logic? Why do we hand surgeons and pilots and paramedics their most critical responsibilities in the first hours of shift that begins at dawn? The answer is that we built our modern schedules around productivity and economics and the logic of sunlight, not around the biological reality of how human brains actually transition from sleep to wakefulness. And we've never really had to confront that mismatch, because sleep inertia is invisible. Nobody looks impaired. Nobody feels impaired. The whole thing happens quietly every morning in hundreds of millions of bedrooms, and nobody talks about it. There's one more thing. The worst version of sleep inertia has a name. It's called sleep drunkenness. Clinically, it's known as confusional arousal. And in its most severe form, it's exactly what it sounds like. People wake up genuinely confused, disoriented, aggressive, unable to form coherent sentences, sometimes for up to 40 minutes. It affects about 15% of adults regularly, and almost none of them know it has a name. So tomorrow morning, when your alarm goes off, you're going to reach over and turn it off. You're going to sit up. You're going to feel like yourself. And for somewhere between a few minutes and a few hours, you're going to be operating on a brain that is still measurably not fully here. Every human on the planet does this every single morning. We just never thought to call it what it is. You don't wake up. You gradually become awake. In most of your life, you've been making decisions in the gap between those two things without ever knowing the difference.